Hello. In this video I'm going to cover the practical design and the use of PLCs based PID controls. My name is James Williams. This is my Module 6 homework assignment. In the outline we're going to cover the introduction, definition of proportional, integral, and derivative PID controls, examples of practical design and the use of PLC based on the PID controls in the industry, advantages and disadvantages of proportional, integral, and derivative PID controls. We'll cover up with the conclusion, and then I'll list my references as well. For the introduction, PIDs are important to many different aspects of systems. I think the most common are VFDs being utilized for conveyor lines. Having the control over the drives helps with the speed control and the ramp up or ramp down, etc. I have worked with many different types of variations of PID systems, like temperature controls, systems for electrical heaters, and they were able to maintain the heat on extruders to keep them ready for use. Another example are mixers that have variable speeds, load cells that have measure batches, recipes, and the sort that make the process very regulated. In my current role, we have testers that use load cells to measure sensors in seats, give speed feedback through resistance values. The definition of proportional, integral, and derivative PID controls. The PID controller then applies corrective actions to bring the PV to the same value and use SPs using three methods. The proportional component responds to the current error values. The integral component considers the cumulative sum of past errors, and the derivative component predicts the future errors by assessing the rate of change of the error. These three control terms influence the controller output to apply accurate and optimal control, ensuring these systems remain stable and responsive to change. Some listed pros and cons of proportional, integral, and derivative controls. Some pros: it's versatile. PID controllers are applied in a wide range of systems, including analog, digital, and mechanical systems. They're cost-effective, generally less expensive than other control methods. They're energy efficient. PID controllers have optimal energy use by adjusting systems output based on feedback. Like I said, with those heaters, constantly monitoring and varying. Ease of implementation: they can be easily integrated into the systems without extensive hardware changes. Tunable gains: PID controllers can easily tunable gains can easily be tuned to achieve optimal performance by adjusting the proportional, integral, and derivative gains. Some of the cons: inaccurate tuning. Improper tuning can lead to system instability, overshooting, or oscillation. Limited applicability: they may not be suitable for systems with significant delay or multi-input, multi-output MIMO systems. Sensitivity to noise: PID controllers can be sensitive to noise or disturbances in sensor signals, affecting accuracy. And complex systems: they may struggle with complex or nonlinear systems, requiring additional techniques or compensators. And then last is performance limitations. In systems with conflicting objectives or constraints, PID controllers may not achieve optimal peer performance. PID controllers remain a popular choice for many engineers due to their reliability and the ease of implementation, especially in stable systems with straightforward goals. However, a more dynamic or complex applications, advanced control strategies may be necessary to overcome their limitations. Here's an example of a PID block. You're having your set point. Obviously, there's going to be an offset with an error, and then the integral, proportional, and derivative all capture the feedback, which feed back to the process, and then loops back to the set point, being able to help regulate and control those errors. In summary, the use of PIDs can make a big difference when it comes to using them to control variables and reduce the constant monitoring and adjustment of systems and sensors. There are drawbacks from PIDs when they are set up incorrectly. They can cause damage or product defects. And the cost of PID offsets the price of allowing time to be freed up for someone having to constantly monitor the system. Here's my references, and thank you very much.